Hey guys, today, Monday, September 23rd, we covered, we went back to 2.4 and we didn't do the notes because we had already done the notes on 2.4, but it's been a while since we finished those notes. So I wanted to come back and do a few of the practice problems, the homework practice problems from the textbook in class, just to kind of, go back over 2.4 again. So we're going to do, I don't know, about 15 or 16 of these. We'll kind of see what we have time for, but we'll just get started, okay? But these are the problems that we did together in class, and whichever ones we didn't do, we finished for homework. So if you're watching this, then all the problems, including your homework ones, should also be done here. So Max has more than 5 carrots. We're going to write an inequality that represents that description and solve it if we need to. So Max has more than 5 carrots. So C is representing Max and his carrots. So C is the number of carrots that Max has, and Max has more than 5 carrots. So the number of carrots that Max has is more than 5 carrots. So there's your inequality that represents exactly that statement. C is bigger than 5. Carrots that Max has is more than 5. Now, if this were to say, instead of more than, if it were to say at least 5 carrots, if it said at least 5 carrots, then it would include 5 and you'd have greater than or equal to. But it doesn't. It just says more than, so it's just regular more than. Number 2, Bridget is shorter than 5 feet. So H represents Bridget's height, and Bridget's height is shorter than 5 feet, so it is less than 5 feet. Okay, number 3. Twice a number, x is the number, so twice x is less than 10. So twice x means 2x is less than 10. So there's our inequality. Now this one's not solved, so we do need to go ahead and solve it. So since we have 2 being multiplied with x, in case you're lost here, I'm trying to solve for x. I want x by itself, which means that this 2 right here that's next to x, I got to get rid of it somehow so that I just have plain old x by itself. Now, since it's 2 times x, we can get rid of the 2 by doing the opposite operation. The opposite of multiplying 2 is dividing by 2. So when I divide by 2, those 2's will cancel out and leave us with just the plain x. But of course, divide both sides by 2, make things balanced, right? So 10 divided by 2 is 5. So x is less than 5. Number 4, 6 more than 5 times a number, x. So 6 more than 5 times x is at least 21. Now, this can get a little bit confusing when we see the words more than. Sometimes we think more than, we actually think of the inequality sign, more than. But in this case, it's not actually referring to the inequality sign. It's saying 6 more than 5 times a number. It means we're adding 6, okay, to 5 times a number. So plus 6 to 5 times x. So we'll have 5x, and then we'll add 6, okay? So 6 more than 5 times the number. Whenever you're doing 6 more than, 6 less than, when you're adding or subtracting, you always want to put that at the end here. Because, for example, if you wrote 6 plus 5x, although it's technically the same thing as this, you'll run into issues when you have the less than. If that were to say less than, and you try to do 6 minus 5x as your statement, it would be wrong. So get used to putting this plus 6 or minus 6, if it, whatever it is in other problems, at the end, last, after you write the 5x, 5 times a number, okay? Now, we still have more to this. It still is at least 21. So if it's at least 21, then it's 21 or higher, right? So that means that all of this is bigger than or equal to 21. So now we just got to solve it. We solve it, we would subtract 6 on both sides. So by subtracting 6, we get 5x is greater than or equal to 21 minus 6, which is 15. And then we can just divide by 5, cancel the 5's out. We have x is bigger than or equal to 15 divided by 5, which is 3. So now number 5. Dave has $15 to spend on an $8 book and 2 birthday cards for his friends. How much can he spend on each birthday card if he buys the same card for each friend? So we have to talk about the amount of money that Dave is spending to his total amount. So Dave is spending $8 on a book, and on top of that, he is spending $2, not $2, but he's buying 2 cards. So $8 on a book, and then he's buying 2 cards. So 8 plus 2 cards, and now he has $15 to spend. He can't spend more than 15 if 15 is all he has. So he can spend up to 15, which means he can spend anything less than 15 or equal to 15, but he can't spend any more, right? So it's less than or equal to 15. So this is the $8 for the book. This is the cards, right? And then the 15 was his total amount. So when we solve this, right, when we're trying to get C by itself, we have to get rid of the 2 and we have to get rid of the 8. Now, rule of thumb is you don't do the C term. We don't do anything that's associated with the C term until last. Save it for last. So anything that's outside of it, we get rid of first. So in this case, the 8, right? We'll get rid of that. So since it's positive 8, we'll subtract it. Now, what this is doing in the context of the problem, we have 2C less than or equal to 7, right? We have 15, or Dave has $15 to spend. 8 of that 15 is going to go for the book, right? So if he spends $8 of that $15 for the book, that leaves him $7 left over for the cards, which is what we've done here. By taking out the 8 on both sides, right, we're removing that cost. It's telling us that we have $7 left to spend for the 2 cards. The 2 cards has to be less than or equal to the $7. Now we can get rid of the 2, right? If I can buy 2 cards for $7, then I need to split the 7 in half, right, to figure out how much I can spend on each card. So dividing by 2, we end up with a card is less than or equal to 3.5, which just tells us that the cards cannot be any higher than $3.50. If it's any more expensive than that, then we'll go over the $15 and exceed our budget. We won't have enough money. So $3.50 is the most that we can spend. The cost of the card is less than or equal to $3.50. Now, number 6, Tony can carry up to 18 pounds in her backpack. Her lunch weighs 1 pound, her gym clothes weigh 2 pounds, and her books weigh 3 pounds each. How many books can she carry in her backpack? So what we have to do is we have to add up all the weight in her backpack until it's up to 18, right? She cannot have more than 18. So she can carry fewer than 18 pounds or 18 pounds exactly. But she can't carry any more than 18 pounds. So let's talk about what she has to add up. What's in her backpack that adds up the weight? Well, we have 1 pound, right? This is from her lunch. Her lunch weighs 1 pound. Then we have to count the clothes, right? Her gym clothes weigh 2 pounds. So between the lunch and the clothes, that's already going to be 3 pounds, right? But we'll combine those in a second. But we have to add, additionally, we have to add the weight of the books. Now, we don't know how many books she's carrying, but we know that they weigh 3 pounds each. So it's going to be 3 pounds per book. Now, this has to be less than or equal to 18 pounds altogether. So this is everything in her backpack, and it has to be less than or equal to the total 18 pounds. So when we go ahead and solve it, we can combine the 1 and the 2, right? The lunch and the clothes combined makes 3 pounds, plus the 3 pounds per book is less than or equal to 18. So just like the last problem, right? I'm not going to try and get rid of this 3 yet because it's part of that B. I'm going to get rid of the 3 that's disassociated from it. So this 3. Since it's positive, I'll subtract it. Now, what this means, again, in the context of the problem is, remember that 3 pounds that we're subtracting is coming from the lunch and the clothes. So if we, 18 pounds can go in her backpack, 3 of those pounds is going to be the lunch and the clothes, which means that there are 15 pounds remaining for her books, right? She has 15 pounds of space left over for her books. Now, each book weighs 3 pounds each. So if we divide by 3, we'll find that each book she can carry at the most 5 books. 15 divided by 3 is 5. So she can carry at most 5 books. Anything less than that's fine, but anything more than that is too heavy. Now number 7. 3 times x minus 2 is greater than negative 3. So in this problem, we have these parentheses, and we have to deal with those parentheses first. So the x is over here, and we have the 3 and the negative 2 we need to get rid of, but we can't do anything about it until the parentheses are gone. So the way we get rid of these parentheses is that there's actually 2 ways you can solve this problem. But traditionally, what most people do is they'll distribute that 3 and multiply that 3 into the parentheses. So we have 3 times x, right? Because remember, we're taking this x minus 2 and multiplying it by 3. So the x times 3 is 3x. And then the negative 2 times 3 is negative 6. So this right here, 3x minus 6, is the same thing as x minus 2, it's just both of these are tripled. Both of these are multiplied by 3. So that's distributing, and that's greater than negative 3. Just bringing all that down. So now we're solving. Now we got to get rid of the 3, and we got to get rid of the 6. Now, because the 3 is associated to x, I'll have to save that for last, which means I'll get rid of the 6 now. We'll add 6 to both sides because that's the opposite of minus 6. And that'll bring down the 3x. 3x is bigger than negative 3 plus 6, which is positive 3. And then we just divide by this 3 to cancel it out. We have our x all by itself, and it's bigger than 3 divided by 3, which makes 1. Okay, so now let's do number 8. Number 8. Here's a mistake a lot of people do. A lot of people see this 5 plus 5 and think, oh, I'll just add them together and make 10. But we cannot do that, okay? Because the order of operations says that we should multiply these things together first before we add, right? Multiplication comes before addition if you're looking at PEMDAS, the order of operations. So do not try to add these together. You have to distribute first, okay? So 5 times x will make 5x, and 5 times 4 makes 20. Okay, so this is just the same thing as those parentheses. But now I'll bring down that 5 plus, I'll bring down the less than or equal to 20, and then we'll solve. So on the left-hand side, I've got 5 and I've got 20, 2 regular numbers that I can add up. 5 plus 20 combines to make 25. Don't forget we still have 5x there and still less than or equal to 20. So I got to get rid of 25 and I got to get rid of 5. Since the 5 is a part of x, right, I'll save that for last. I'll get rid of the 25 first. So subtract 25, because that's the opposite of adding and positive 25. We have 5x is less than or equal to 20 minus 25 is negative 5. And now I just need to divide by 5. Dividing by 5 cancels that out. We have x is less than or equal to negative 5 divided by a positive 5, which makes negative 1. So now number 9. Number 9's got a fraction, but doesn't necessarily make it, well, I guess you can kind of make it hard. It's just we can ignore the fraction a little bit. We can use a decimal in its place in this problem. It wouldn't hurt. Since I don't see any other fractions, I think changing it to decimal would be fine. If I saw fractions everywhere else, like if I saw this as a fraction, this as a fraction, then I'd probably leave it as a fraction. But since 1/2 is the only thing, that's probably not going to be too big a deal if we just change it to a decimal. So, same as the last problem, right? We cannot add these together first. What we need to do first is we need to distribute the 1/2. 1/2 times 3 and 1/2 times negative x. So if you're doing that, remember we're going to consider the 1/2 to be 0.5 for the sake of, I guess, just being a little bit more simple. 0.5 times 3, or half of 3, is 1.5. And then 1/2 times negative x is just 1/2 x, or 0.5 x. Now we can still have this 3 plus at the beginning, and we can still have less than negative 7. But I took my 1/2 and multiplied it into the parentheses to get that 1.5 minus 0.5x. So I see here that I've got these two numbers. I can combine 3 and 1.5. I can just pop them together. 3 plus 1.5 makes 4.5. and then I'll bring down minus 0.5x less than negative 7. So again, I got to get rid of 4.5. I got to get rid of negative 0.5. But because negative 0.5 is with x, I'll save that for last, and I'll get rid of the 4.5 first, just like we've done in the past several problems. So doing that, we'll be left with negative 0.5x less than negative 7 minus 4.5 makes negative 11.5. And now we'll divide by negative 0.5. Now, something interesting happens here because we'll be left with x all by itself. And then negative 11.5 divided by 0.5 is 23. But notice we used to have a less than sign, but now the answer is actually x greater than 23. So I'm flipping the sign here. Now let me tell you why I did that. It's all based off of this step right here, what I did in that step. Anytime, this is the only difference between a regular equation and these inequalities. Anytime you divide by a negative, right, or you could multiply by a negative as well. Anytime you divide by a negative, though, it's more common, you will have to flip your sign. Okay, so because we divided by a negative, right, that's the reason why we're flipping the sign. We flip sign when divide by negative. Okay? It doesn't matter if that 11.5 there was negative or not. That would not matter. It's only going to matter if it's dividing by a negative. If I divide by a negative 0.5 like I did, I need to flip my sign. Okay? If I divided by a positive 0.5, I wouldn't have had to flip the sign. Sign would have stayed the way it was. But because it's a negative number that I'm dividing by, a negative 0.5, I need to flip that sign. So now let's look at number 10. So number 10, it looks longer and it looks a little more complicated. However, it's no different than the problems we've already done. It's a few more steps maybe, but all the math is still the same. Like in the previous problems, we had to distribute first, and that's exactly what we're going to do first here as well. We're going to distribute just like we've done in the past. So that step's not any different. We should all be able to do that. The x times 3 makes 3x, and the 6 times 3 is 18. And for the second one, x times negative 2 would become a negative 2x, and positive 2 times negative 2 makes negative 4. This is more than or equal to 10. Now, the only new thing on this problem is the fact that we've got like terms to combine. So you'll notice 3x minus 2x, these two terms we can simplify and we can put them together. We have a lot over here right now for these four terms. But because there's pairs that match, we can simplify it by putting those pairs together. So 3x minus 2x, we can put that together, and 18 minus 4, we can put that together because those are like terms. So 3x minus 2x becomes 1x, and the 18 minus 4 becomes 14. It's a positive 14, so it's x plus 14. And of course, it's still greater than or equal to 10. So when I solve, I just got to get rid of the 14. The way to do that is subtract 14. That'll cancel it out. We'll have x is bigger than or equal to 10 minus 14, which is negative 4. So now number 11. Number 11 is pretty much the same thing as number 10. You know, we got to start by distributing both sets of parentheses. So 5 times 3 is 15. 5 times negative x, negative 5x. And negative 4 times 2 is negative 8. And negative 4 times negative 3x is positive 12x. So we got to be careful about that those negatives turning into positive there. Greater than 2. So just like the last problem, I got pairs of like terms that I can combine. I've got these x terms that can go together. Negative 5x plus 12x is 7x. I also have 15 minus 8 that can go together. Put those together. So negative 5x plus 12x is positive 7x, as I mentioned. And then 15 minus 8 will also make 7, positive 7, so plus 7. And this is going to be bigger than 2 still. I'm going to line these up a little bit better. these go to make that 7. There we go. All right. So I got both of these 7s I need to get rid of to get the x by itself. Since that 7 is with the x, I'll save that one for last. I'll get rid of this 7 first. So I'll subtract this 7 to get rid of it. So that's going to leave me 7x bigger than 2 minus 7, which is negative 5. And now I can get rid of the other 7 by dividing it. So here's our answer. We have x all by itself, and it's equal to, or not equal to, but bigger than just that fraction, negative 5 divided by 7. You could just write it as negative 5 over 7. And there was no sign flip here because I didn't divide by a negative, right? 7 is a positive number. I divided by a positive 7. The sign does not flip. The negative 5 is negative. That's cool and all. That doesn't make a difference. It's only the number I'm dividing by that matters. Since I'm dividing by a positive 7, that's what matters. All right, I'm going to end the video on that problem, guys. If there's any more of these I'll do them in a separate video. But I know this one's getting a little long. So see you guys next time.